the quantum gravity breakthrough. OpenAI's latest model just derived entirely new results in theoretical quantum gravity that human physicists had not yet documented. This isn't a retrieval of old data or a clever summary of a research paper. In a technical reveal on May 5th, researchers confirmed the model used zero-shot inference to solve structural derivations that previously required weeks of supercomputing time. This marks the moment artificial intelligence moved from repeating human knowledge to generating original scientific logic. The death of stitched architectures. Previous models were essentially multiple brains wearing a single mask. One part handled text, while another was grafted on to process images or audio. This created a reasoning gap where the model could describe a falling glass but didn't actually understand the momentum involved. GPT-5.5, released just 3 weeks ago on April 23rd, changed that by using a unified architecture. In this system, video data and linguistic tokens share the same neural pathways. When the model processes the word gravity, it isn't just looking up a definition. It is accessing the latent weights formed by watching millions of hours of physical motion. This native omnimodality allows the system to simulate physical consequences before it ever types a single word. Why vibe physics works. Engineers are calling this phenomenon vibe physics. It sounds informal, but the mathematical reality is rigorous. By training on raw video without human labels, the model has developed an internal prior for how objects behave in three-dimensional space. It understands weight, friction, and tension through observation rather than programmed rules. This solves the reasoning gap, because the model no longer guesses the next word based on probability. Instead, it predicts the next state of the world and describes that state back to you. This is why it can now solve complex engineering failures in structural models that stumped every previous iteration of GPT-4. The hallucination of gravity. We must address the risk of high-fidelity errors. Because the model relies on physical intuition rather than a hard-coded physics engine, it can occasionally simulate a world with slightly different constants. It might predict a structural failure point with 99% accuracy, but fail on the remaining 1% because its internal version of friction is slightly off. We are seeing a transition from linguistic hallucinations to physical ones. This creates a new challenge for verification, where we need to check if the AI is a brilliant engineer or just a very convincing dreamer, the part no one wants to say. The fundamental shift we are witnessing is the transformation of large language models into general world models. By integrating implicit physics directly into the reasoning backbone, OpenAI has bridged the gap between talking about things and understanding how they work. This change, highlighted by the recent quantum gravity derivations and the unified architecture of GPT-5.5, means we are no longer building chatbots. We are building simulators that can verify their own logic against the laws of reality. For builders and operators, the implication is immediate. The value of prompt engineering is collapsing, replaced by the value of physical world testing. If you are developing robotics, autonomous design, or materials science, you are now working with a system that has a better gut feeling for physics than most human graduates. The next milestone to watch is the June 26th Robo-Logic integration, which will attempt to link this internal physics prior to real-world actuator control in a closed-loop system. Subscribe for more.